Hi there folks, welcome back to another video in this Battleship series. In the last video we created the buttons and added their functionalities, the randomize button, the reset button, the game deployment buttons. In this video we want to do a couple more things. We want to update the player's game logic as well as the computer's game logic with the position of the ships. And then once we've done that, I think we want to create the player object as well as the computer object, and give them a method to allow the player to actually make a turn, and then it will be the computer's turn, and then it will be the player's turn again. Alright, so in order to do that, the first thing we need to do is we need to come back into here in order to create what was the first thing we wanted to do? We wanted to update the game logic. So in order to do that, we're going to come back here. So in my utility functions, you'll see I'm here at my update game logic. Now I've created the name of this function misleading. I'm going to change it to say create game logic, and it means we have to scroll back down to our player game Pygame logic, change that update to say create game logic, and under the computer game logic I need to change it to say computer create game logic. Alright. Coming back up to this function create game logic, directly underneath it, we're going to create a function called update game logic. And when we want to update the game logic, we're going to need the coordinates grid. We'll need the ship list as well as the game logic. Okay. A little descriptor, update the game grid with the position of the ships. Easy enough, straightforward. Let's go for it. So the first thing we'll do is we'll start off with a for loop. So for I and row X in enumerate coord grid. I'm not so much looking for what's inside the coordinates grid. I'm looking for the index number. And then for J, call X in enumerate row X. Again, I'm looking for the actual index number. Right, so once we've got those, we're going to go with if game logic I J is equal to T, which would represent, in this case, for my game, a ship, but a hit ship position. Or if game logic is equal to X, which in my game would represent a selected cell, but that was a miss. Right? We will just tell the for loop to continue on to the next loop. Else game logic I J should then be equal to space. Right? But we just want to do one more check after, which will say for ship in ship list. And now we're going to create for each cell of the coordinates grid, we're going to create a rectangle and check if the rectangle collides with the rectangle of the ship. If Pygame.rect, and we'll call x 0, call x 1, cell size, dot collide, rect, and then it will be ship.rect. So if Pygame.rectangle collides with the ship.rectangle at this particular cell logic, then we say this game logic position J will then be equal to O, which is my representation for a ship in this game. Alright, so what I'm going to do now is we're going to call that function update game logic I think we need to call it every time we randomize the ship positions, we need to call that game logic. So here in my randomized ship positions, the end of it, we're going to say call update game logic, and the we're not going to call it there, we're not passing much functions to it. We could actually call it in our main game loop. We could call it in our draw function. So let's call it our update game screen function. I think we put it there. Let's do it. Show grids on the screen. Let's do it here. Update game logic, and it'll be the first one will be player game grid, player fleet, player game logic, and then the second one will be update game logic, player computer game grid, computer game grid, computer fleet, computer game logic. Right. So we've got that there. Now I want to be able to double check this, so I need to call this function. I want to be able to call this function on demand, so it prints it to screen. Where was the function we created? Print the game logic. I want to be able to call this on demand. So I'm going to go down to our main for loop. In between our if event button is equal to 1 and if event button is equal to 3, I'm going to create another little elif statement here. So elif event button is equal to 2, which is our scrolling mouse button, our scrolly button. If that button is pushed, I must then call the print game logic. Right. Let's give the game let's give it a whiz. The game is running. If I push the middle mouse button right now, what happens? Oh, so there's the player grid. There's no ships on the grid, which is what we expect to see. No ships on the grid. However, when we get to the computer grid, let me pull out the computer screen. So we have in the first row, there's one ship, part of a ship there. And if we look on the actual computer's grid, there's a ship there. The O's appear to be working, appear to be reflecting in the correct places. That's fantastic. I'm going to place my ships on the screen instead of computer ships changed. I'm going to recall this print function. So the computer ships are all bundled up again. Player ships are all there. I just want to see if I move the ship. I had this issue before, and I place it there. And I recall my grids. Nope, it's working correctly. Alright, so we have representation. We're picking up the positions of all of our ships on the grid. If I try to randomize the positions and I call this function again, I'm printing the function again. The grid is automatically being updated with the new positions of the ships with each cycle of the update display screen. Okay, so that's working fine, and now my game logic is working correctly. We need this game logic grid because that's the grid that the computer will be using to select at random which ships he's going to, which cells he's going to be selecting to attack. That will be the computer easy level, which will be straightforward. They'll be selecting at random a row based on an integer, a random integer between 0 and 9, and then he'll be selecting a column based on a random integer between 0 and 9. And then I'll just do a basic check to make sure that that's a valid position. If not a valid position, he'll make another selection. Right. So now we've created the checks and we've updated the game grids, the game logic grids. let's go ahead and create our player class. Okay, let's go all the way back up to the top. I'm just going to minimize that now. We don't need that. I'm going to minimize the create game logic. That's sorted. Now buttons for now. We can hide this class in total. And we're going to add a new class here. It's going to be class player. Alright. It's going to be a very basic class. There's not a lot of details in it. It's just straightforward. It's just straightforward. There's not even any arguments passed through. It's just self.turn is equal to true because the player starts off first. And we're going to create a method and say make attack self and grid. Alright, let's give a descriptor. When it's the player's turn, the player must make an attacking selection within the computer grid. Right? And then we're going to go ahead with, so the basic things first, we're going to say pos x, pos y would be equal to pygame.mouse.get pos. Okay? And then if pos x is greater than or equal to grid 0, 0, 0, and pos x is less than or equal to grid 0, minus 1, 0, plus 50. And pos y is greater than or equal to grid 0, 0, 0, 1, and pos y is less than or equal to grid minus 1, 0, minus 1. Sorry, 1 plus 50. Okay. So if that's the case, right, so that's basically checking if the mouse is clicked within the completed grid. The next thing we need to say now, we need to do a collision detection check. So we're going to say, we're going to go with for I, row X, and enumerate grid. J, call X, and enumerate row X. If pos X is greater than or equal to call X 0, and pos X is less than call X 0 plus 50, right? And pos y is greater than or equal to call y 1. What's wrong with that? Call X, not call y. Call X. And pos y is greater than or equal to call X 1. And pos y is less than or equal to call X 1 plus 50. Right. If that's the case, and another if check. If you can see here now we have to check grid. The grid is grid coordinates. We actually need to pass the logic grid as well. Logic grid. Good. If logic grid I j does not equal a space, right? Which basically means if it equals a circle, if logic grid does not equal that, and logic grid I j does equal a 0 or an O, right? If that's the case, then we would print to the terminal hit, and then we're also going to logic grid I j, and then we change to a t. Okay. Then obviously then our self.turn will be to false because our turn has ended. Else logic grid I j then equal to x because it's a miss. And then it's self.turn to false. Right? And that's basically all we need for the player character, the player object. It's just a make attack selection. Right. Now we need to find a way to be able to call that. So if we go down to our event handler in our main game loop, for event button, if mouse button down 1, if event.button is equal to 1, deployment being true. Okay, here. If deployment is equal to true. Alright. Else, if deployment is not true, then it's actually in the middle of the game stage, and we will say player character. We're not calling it player anymore. So let's say player 1. Let's call the actual character the player object. Player. Let's create the player object. So else player 1 dot make attack. And then the grid that will be computer game grid C game logic. So else, right? There is also only if player dot turn is equal to true. Player 1 turn is equal to true. Right. So we can set this function up. We'll only be able to use it once because there's no way that the player 1 will turn can be set back to true. Let's deploy. I'm going to make a selection. I'm going to make a pass. Let's test the ship. So I'm going to make a selection of the ship. My terminal, receive the word hit. Obviously, there's nothing displaying on the screen at the moment, so there's no way that we know. However, if I do the middle mouse button, I print the grid. On the computer grid, we should be seeing a T. And there it is. There's the T to indicate that we have hit the ship, which seems to be working correctly. I shouldn't be able to make another selection at the moment. Nothing can happen. To reset, but nothing. Randomize, nothing. Anyway, let's just run it one more time and make sure. Run it one more time and make sure the empty spaces are also working. This is randomize, deploy, and if I hit a random empty space, obviously that doesn't print to the terminal because we didn't tell it to. I'm just going to print the logic grid boards again. There should be an X on the screen. On the computer grid, there's no X. Why is there no X's? So we'll try that one more time. I'm not sure. Maybe I didn't click. Let's try it again. Randomize, deploy. Okay, we are in the game. If I select that square there, I'll print the game. Computer logic again. Let's move the game screen out of the way. Okay, I'm not getting an X on the game logic screen. Why not? Let's go back up to our make attack. So if the logic grid RJ does not equal a space, and I think in my make attack method, I think that should not be an and, I think that should be an or. Right? So if we run it, let's try it again, randomize the ships, deploy. I want to select the top right, top left cell, which we can see currently as a space. Select it, print the grid again, still nothing. Still nothing. Yeah, you see, I was trying to be clever. Okay, so in my main method, my make attack method, I actually need to have this check if it's a logic grid, if it's a ship space on a separate line. There, so if logic grid RJ is equal to ship, that needs to be its own check, and all of that can be multiplied forward. So basically, I'm checking to see if the logic grid RJ is not a space. And then if it's a ship or if it's a T, otherwise, if it's not equal to a space, I must make it X. So while we're doing that, let me just print this and make sure that the function is being called correctly. Randomize, okay, let's deploy the game. If I click in the bottom left corner, and this, that means the logic has been updated. No, it hasn't. Why not? That should be an X. Why is that not an X? I think there's a problem here in the update game grid, update the game logic. I think the mistake's lying here. In the updating the game logic function. Right. If game logic ij is equal to t or if game logic there we go. I, J. So in my update game logic, I had left out the grid coordinates of the grid, so it wouldn't update for the X. It would just override it all the time within the space. So that's why if we run this again, I analyze my ship position, and I deploy, and I select the bottom left corner. It's a miss, so it's called correctly. Print the game grid now. There's that X. Beautiful, beautiful X. Exactly what we were looking for. Fantastic. Alright. We're happy with that. It's working. It's doing what it's supposed to be doing. I think we'll keep the print miss and print hit because we need to come back to this function a little bit later to add the little tokens to the screen. But I think before we do that, I think we can just add the easy computer player. It's fairly straightforward, fairly easy to do. It's a fairly straightforward function, object, and I think we can do it quickly in this video, and then it's time for me to go to bed. The class easy, let's say class easy computer, right, def under init, just self, no arguments needed, self.turn, obviously we'll start off with false, self.status will be equal to self.computer status. Okay, which is a little method we're going to create in a moment. And then self.name will be equal to easy. Straightforward, that's our initialization of the computer object. Let's just go ahead and create the computer status method quickly. Computer status, self message, right. The descriptor, for this we don't need the descriptor, it's just going to be straightforward. Image will be equal to pygame.font. Pygame.image. No, pygame.font.sys font. It will be stencil again. I like stencil, it's very nice for me. The message will be equal to image.render message 1 and black, which will be 0, 0, 0. And we want to return message. Come on, return message. Okay. Next thing we want to do is we want to say define make attack, and we're going to pass to it same as the player grid. We're going to pass to it the grid and the game logic. Okay. So the first one we're going to go with is we're going to make a variable called valid choice. Set that to false. Then while not valid choice, while not valid choice, we're going to go x axis. Let's call it row x. It's going to be equal to random.rand int 0, 9. Yeah. And then col x will be equal to random.rand int 0, 9. Okay. Now we just need to do a check to make sure that that grid position is correct. If game logic x call x is equal to, or game logic row x call x is equal to ship. So if that's true, valid choice equal to true. And therefore we would then break out of this while loop. If it's not a valid choice, the while loop will just continue once more time. We'll just carry on selecting random positions, random row, random column, until eventually it finds the correct, finds a valid position to select. Then outside of this while loop, we then need to go with or what is it? What happens? So if game logic row x call x is equal to a ship. Remember, the circle 0 O represents a ship. We'll then say print hit player's ship, just for now, so we know that it's checking it up correctly. And we're going to, on the game logic being passed to it, we're going to go x call x will then be equal to t. And then that will be end of self.turn, lecture false. Okay. The next thing we're going to go with is else game logic row x call x is equal to blank space. Game logic row x call x is equal to game blank space. I don't actually need to say that. I just need to say game logic, because we've already done the check to make sure that it's not a T or an X position already. So game logic row X call X therefore will be equal to X position, and we will print missed and self.turn false, and then we will also return self.turn. Alright. There's one more method I have here, and it's a very quick one. I think we'll forget about it later on. I think it will help us just to see what's going on. So we're just going to say define draw method to the window, it's an additional argument with self.turn window.lit self.status, and the position will be C game grid 0, 0, 0 minus cell size C game grid -1 -1 1 plus cell size. Like attack. Put this grid normal grid there. I don't actually need that argument. Just the game logic. So in our main game loop now, right at the bottom, we're going to add a little bit of a check to see whose turn it is. So what we need to add is right at the bottom, even underneath the update game screen, we're going to go with, we're going to create a function called take turns. We're going to pass it player 1 and computer 1, or just computer. Let's just call it straightforward computer. So we need to create computer player, so computer will be equal to easy computer. And the second thing we need to do is we need to create this take turns functions. Under my utility functions, under deployment phase, we're going to create a function, take turns, with P1 and it's P2. Okay, I'm going to take turns. Take turns, utility function. And the utility function for take turns is pretty straightforward. It's really straightforward actually. If P1.turn is equal, if P1.turn is equal to true, turn is equal to true, player 2's turn must therefore equal false. Else P2.turn will equal to true. Right. And if not P2.turn, if not P2.make attack, player game grid. No, game logic. Player game logic. If not P2.make attack, pass the player game logic. So basically the return from that method, if it's false, then P1.turn equal true. Alright, so we should basically be able to play a quick game right now. The computer player draw thinking to screen. That's interesting for me. Where did I pull that out? Okay, display ships. Computer.draw window. So on my update game screen, at the bottom here, underneath update game logic, okay, let's say above the game logic, the loaded buttons, we're going to say computer.draw. If I run the game now, I should be able to play the game for a little bit actually. So run my ships, put them on the screen, deploy the game. I will select this position. Turned out to be a hit. Let me just reprint out the game screen. Let's make the game screen bigger. Alright, so there we go. So I made a hit. The computer player made a miss. It's my turn. It should be my turn again. So I will now select that square. Gives me a hit. Computer player made another miss. Let's print out the game screen. So I've got two T's. The computer player has an X and an X. That's fantastic. So I'll make that one my turn. The computer missed. Let's print it out. I've got the player. Wait, what's happening now? Oh, sorry. I've got three T's. The computer has one X, and there's another X. So currently we are actually busy playing Battleships. We reprint the screen again. He just barely missed my ships. And if I do this, I'll destroy his carrier, and he's still missing all my ships. 1, 2, 3. Oh, that one was close. 4, 5. If I now destroyed his Battleship. He's missed again. I hit that one. He's missed again. I'll hit that one. And he's finally made a hit on one of my ships. Let's print out the grid. Where did he make a hit? There. He's finally made a hit on that ship. Busy destroying his. Right, so we basically have a semi-functional computer game. Battleships. The only issue is we have no tokens displaying to the screen, nothing to show that the squares have already been selected. I think that's what we'll build in the next video. Right, it's now very late. I have work in the morning. I hope you guys enjoyed this video, and I will see you guys in the next one. Bye for now.